On the screen, you see a system that has been defined by the state space form. And we have on the left-hand side the inputs, and the right-hand side the output. So the objective here is how can we obtain the transfer functions from the state space form that we have in here. So this in here is my input on the left-hand side. I'm going to write down this is my input in here, or inputs, and these are the outputs. Okay, so you have a system that has been defined by this. This is called state space form. So you have it that x dot is equal to the matrix A times the vector x plus the matrix B times the vector u. This is this, right? And then you have that the output y is the matrix C times the state space vector plus D times U. Okay? This is obviously the time domain equations. Our title of our explanation today says transfer functions from the state space form. So that's our objective. Our objective is to obtain the transfer function. You will say objective here. Okay. I will say obtain the transfer function using the state space form. Okay, how do we go about doing this? All right, here we have the equations in the time domain, and in order to do this, we should apply the Laplace transform as we did on the a little earlier in the video, a little earlier, to obtain the transfer function. We are going to apply the Laplace transform, but to the system of equations, not just to one equation, but to a system of equations. That's why these wiggly brackets indicate not just one quantity, but the whole vector there. So why don't we do this? We'll go and say, okay, isn't it true that if we I'm going to say here, apply the Laplace transform and so in here you're going to say this would be S times x of s, like this, vector equal to the matrix A times the state variable vector, which is x of s, okay, plus the matrix B times the input vector, which would be u of s, yeah? And then we have over here that y of s is equal to c times the vector x of s plus the matrix D times the vector u of s. You see, we are interested in our objective to obtain some sort of a relationship of the output in relationship to the input, see? This is what we want, because that's what a transfer function is. So in order to do this, what I suggest we do is we obtain, we have two equations, two unknowns over here. Now we have to obtain the, here we go. We need this ratio here. So here's what I would suggest. Let's put this on the same side. S times the terms of x of s minus you have a times x of s, right? This is equal to b. I just move one term to the other side, right? So isn't it true that this is to be able to do this, we have to put it into matrix form. Because this is a vector here, to add to this we'll have to multiply by the identity matrix. So this would be S I minus the matrix A, like this, times the vector x of s is equal to what we have on the right hand side. Okay, now if we multiply by the inverse, with IA minus A inverse times S I minus A times x of s this would be equal to Si minus A times B, right? Times U of S. All right. So you could conclude that the vector x of s is Si minus A inverse times B times U of s. If you replace this, see, I like this pattern here. If you replace it in here, okay, see, what do you get? You're going to get, let's just say y of s. I'm just gonna remember these are vectors. So this is equal to the matrix C times what? Si minus A inverse times B times the vector U of S plus D times U of S. Okay, very good. So if this is true, you see you can write down that y of s is equal to C times Si minus A inverse times B plus D. This whole thing multiplied by U of S. See? If this is the case, then it follows that we can write this ratio that we are looking for. The y of s over the vector u of s is equal to this c, no, not c, to the matrix C times the matrix Si minus A inverse, then B plus D. Wow, this is the set of transfer functions. So this is an important little demonstration that we should always keep in mind, that knowing the state space form, by multiplying the matrices this way, we can obtain the transfer function. So it follows that you can, if you know the state space form, you can actually obtain the transfer function for any system, and that is how we obtain the transfer function, knowing the matrices A, B, C, and D, which is what state space form. The next class or video we will see an example of this.